Alright, here are the video notes for lesson 1.3, focusing on linear equations and two variables. It's going to be mostly a review of Algebra 1 material with slope-intercept form, point-slope form, how to find slope, how to sketch some of these graphs, and then at the end, how to kind of put it all together when given certain information. And so we will get right into it. First thing, take notes on it, is slope-intercept form, y equals mx plus b. This is the case where m is your slope and b is your y-intercept. We'll see how we use that slope and that y-intercept when we're asked to graph these. Next, different types of lines. We can get a vertical line. A vertical line is going to happen when you have x equal to just some number. A horizontal line will happen when you have y equal to some number. And a diagonal line will happen in the form y equals mx plus b. When you have a slope-intercept or a y-intercept and a slope, you'll have some kind of slanted diagonal line. Let's start seeing what those look like with a sketch. The first one we have, this is really 2 over 1, so our slope is 2 over 1. Our y-intercept is 1. What that means is we start here at 1. We have a point. That's our starting point on our y-intercept there. We call it a y-intercept because that's where our line is going to intercept the y-axis. Then we use our slope to build the line, 2 over 1. So what we do is we go up 2 over 1, up 2 over 1, up 2 over 1. Positive 2 over positive 1 is the same thing as negative 2 over negative 1 because two negatives make a positive. So you could also go down 2 over 1 to the left, down 2 over 1 to the left, and create your line there. And hopefully you end up with a line that looks something like this. Okay, same kind of thing for the next one. Different slope, same kind of thing though, where now our slope is equal to negative 2/3. Our y-intercept is 2, so we're going to start here at 2. Again, that's where our line's going to cross the y-axis, and that's why we call it the y-intercept. And then we have negative 2 over 3, so we can go down 2 to the right 3, down 2 to the right 3, or we could see this as a positive 2 over a negative 3. So two different ways to see it. You can see it as negative 2 over 3, or you could see it as positive 2 over negative 3. Both are the same thing. In the top case, or the right case here, that means up 2 to the left 3, up 2 to the left 3, and we can complete our line there. We just got to connect our points. And so we have another line right there. By no means is it perfect because of my dots, but something along those lines. Right there. Okay? Moving on, we have a case kind of like we talked about here, where you have a vertical line or a horizontal line. This looks like it'll be a horizontal line because it's y equals just a number. And so what that means is we are up here at 2, and we have a horizontal line at 2 there. Here we want to get it into slope-intercept form so we can read it a little bit better. So we got to move this x onto the other side, and we end up getting y equals negative x plus 2. That's a slope of negative 1 over 1. And so we start up here at 2, and oops. We start up here at 2, and then we can go down 1 to the right 1, down 1 to the right 1, or we could go up 1 to the left 1, up 1 to the left 1, and we have our line forming. Again, this is a major review of Algebra 1 material. Always just remembering we want to see it in y equals mx plus b. That's the easiest form to graph it with. So if we need to move things around to get y by itself, we have to do that, and then just making sure we know what our slope is and our y-intercept so we can build the line. Say that we don't know what our slope is and we need to find it. Well, if we're given 2 points, we can always find a slope of those 2 points, slope of a line between those 2 points. You'd have a point like x1, y1, x2, y2. Say those are the 2 points you're given, then you can use this equation, the change in y over the change in x, to figure out what your slope it would be. So a couple problems like that. This would be like your x1, this would be your x2. Sorry, that needs to look more like an x. This would be your y1, this would be your y2. Same thing with all of them in this case, x1, x2, y1, y2, and then you can use that slope formula. So you can do 1 minus 0 over 3 minus a negative 2. That would give you 1. 2 negatives here make a plus, make a positive, so that's actually 3 plus 2, which is 5, and I'd have a slope of 1/5. Same kind of thing for b, x1, y1, x2, y2, and so you can do 2 minus 2 over 2 minus a negative 1. We get 0, 2 minus a negative 1 gives me, that turns positive again, so that's 0 over 3, which gives you a slope here of 0. All right. If we keep going, same kind of thing, we're just repeating it. x1, y1, x2, y2, it means negative 1 minus 4 over 1 minus 0. That's going to give me negative 1 minus 4 is negative 5. 1 minus 0 is 1. Gives me a slope of negative 5. And lastly, we have x1, y1, x1, y1, x2, y2. You have 1 minus 4 over 3 minus 3. 1 minus 4 is negative 3. 3 minus 3 is 0. We cannot divide by, we cannot divide by 0. There's no dividing by 0 in math. Your calculator wouldn't let you do it. So what we say is that slope is undefined. Undefined slope. In those two cases, B and D, if you have a slope of 0, say that's my x and y axis, a slope of 0 would just be a horizontal line. An undefined slope would be a vertical line. Slope of 0 means it has no rise. Undefined means it has no run, only rise. Moving right along here, we have point slope form, where m is again your slope, and x1, y1 would be a given point. So if they give you a point to say, hey, it's got to go through this point, and you're given a slope, then you want to use point slope form. It's the most useful form for finding equations of a line in these given circumstances. And so I got my slope, my point that the line must go through. Okay, so point slope form, they'll say, here's a slope, or you'll have to determine the slope using parallel and perpendicular properties, and they'll give you a point that it'll say that there's a point that this line must go through. So that's when you want to use point slope form, and you'll see that in these next problems here. So it's saying we have a slope of 3. We got a slope of 3, so m equals 3, and it's got to go through a certain point, 1, negative 2. And so that would be like my x1 and my y1. And point slope form is y minus y1 equals m x minus x1. And we plug things in, so you get y minus a negative 2 equals 3, because that's my m, x minus 1. This is really y plus 2. And then I am going to distribute my 3 into these parentheses. So the 3's got to multiply to the x, and the 3's got to multiply to the negative 1. So this becomes 3x minus 3, minus 2 on both sides. You end up getting your slope-intercept form. where y is by itself, and you'll have y equals, that looks like an x, sorry. You'll have y equals 3x minus 5. And there's your equation of a line with slope 3 that goes through the given point. And it is the slope-intercept form, y equals mx plus or minus b. Okay, for part B, we are given 2 points. So what we're going to do, similar to what we did here, we're going to use the 2 points to find the slope, and then use one of the points for point-slope form, and eventually work it out to slope-intercept form again. So the first thing we got to do y2 minus y1 over x2 minus x1. So we got 10 minus a negative 4 over 6 minus a negative 1. That gives me 10 minus a negative 4 is the same thing as 10 plus 4, so 14. And then I have 6 minus a negative 1, that's like 6 plus 1, so that is 7. And that reduces down to 2 over 1, or simply 2. So now I have my slope of 2, and so I can use my slope, point slope form, mx minus x1. Plugging in, I'm going to choose, you could choose either point, I'm going to choose this one. And so I'm going to plug in using that, which is y minus a negative 4 equals my slope, which is 2, x minus my x1, which is negative 1. This is now, after I change some things around, minus a negative 4 is the same thing as plus 4. 2x minus a negative 1 is the same thing as plus 1. Got to distribute this 2 in the next step, and so this is y plus 4 equals 2x plus 2. And lastly, got to subtract that 4 over, so y is by itself, and then it's in slope-intercept form, and we get y equals 2x minus 2 as my final answer there. Moving along, we have a couple little notes here. Parallel lines have, we're talking about slopes here, so parallel lines have slopes that are equal, meaning if you have a line with a slope of 1/2, the line that's parallel to it will also have a slope of 1/2, and perpendicular lines have slopes that are opposite reciprocals. Hopefully you remember that term from geometry last year, or from maybe algebra last year too. Slopes that are opposite reciprocals. I spell reciprocals wrong all the time. It's okay, as long as you know what it means. And just as a reminder, opposite reciprocal is if you have a slope of 1/2, the opposite reciprocal would be negative 2 over 1. Reciprocal means that it flips. So the 2 goes on top, the 1 then goes to the bottom. And opposite means that if the first one's positive, the second one has to be negative. A little different. Say it starts negative, and we say we start with negative 3 over 4. The opposite reciprocal of that is going to be a positive 4 over 3. Again, flipping top and bottom, and if one is negative, the other has to be positive. That's why they say opposite. Last thing, I only have a minute left, so you can take a look at the problem. I'm going to pause, and I'll finish the rest of the slides in the second video.